moment Optimus walked on stage, it moved with a level of balance and smoothness that didn't look robotic anymore. It looked almost natural. Humanoid robots have been showcased by companies all over the world, but most of them still move with stiff, jerky motions that instantly reveal their mechanical nature. That's why the latest appearance of the Tesla bot drew such intense attention, even though the units shown at the 2025 shareholder meeting were only Optimus 2.5 development prototypes. They demonstrated a level of motion control that clearly set them apart from what other companies are currently presenting. Their steps were steady, their transitions were fluid, and every movement looked calculated rather than clumsy, but those prototypes were just a preview. The real centerpiece is Optimus Gen 3, Tesla's first official commercial humanoid robot, arriving early next year. This version is being engineered with a design that leans strongly toward human proportions, cleaner structure, and minimize visible mechanics. It's built to appear more like an everyday assistant than a lab experiment. Alongside the design overhaul, Tesla plans for Gen 3 to launch with a wide library of practical tasks, covering everything from home-related routines to workplace assistance. Future updates will continue expanding that skill set as the robot software matures. Looking further ahead, Optimus Gen 4, scheduled for release later on, is expected to bring a much deeper transformation internally rather than visually. It's planned to feature significantly improved intelligence, better precision handling, faster operation, and a larger range of tasks, especially the kind that require delicate or highly controlled movements. It will build on the foundation of Gen 3 while pushing the design toward far more advanced capabilities. Meanwhile, tech companies from China, the US, and Europe are racing to introduce their own humanoid robots. Many of these projects receive bursts of attention, but most demonstrations still show robots that struggle with balance or appear limited to scripted showcases. That's why Optimus is rapidly becoming the model everyone compares against, not because it performs eye-catching stunts, but because it represents a practical, scalable, and realistically manufacturable approach to humanoid robots. Instead of focusing on flashy demonstrations, Tesla is aiming to create a robot that can function in real homes, real businesses, and eventually in large-scale industrial environments. This difference in direction is exactly why Optimus is emerging as one of the most promising humanoid robots in development. Today, not as a prototype for show, but as a product intended to integrate into everyday life. Over the last several years, Tesla has quietly rebuilt the entire Optimus platform from the ground up. The early versions from 2021, slow, unsteady, and visibly experimental, have been completely replaced by the far more refined Optimus 2.5 prototypes we see today. These updated units can steady themselves after being pushed, maintain balance on uneven surfaces, and perform much more coordinated hand movements. What makes them stand out is the ability to handle delicate items without crushing or dropping them, something that's extremely difficult for a humanoid robot to do reliably. Beyond the basic mobility, Tesla has been steadily training and refining Optimus through simulated environments. This training allows the robot to develop new skills without physical trial and error, which speeds up learning dramatically. As a result, Optimus 2.5 has already demonstrated a variety of practical household tasks: vacuuming, wiping surfaces, taking out trash, stirring food, organizing small items, and even assisting with simple event tasks like handing out popcorn or candy. These early abilities show where the technology is headed, but they're only a preview of what the retail versions will be capable of. Optimus Gen 3, arriving next year, takes all of this progress and packages it into a more complete product. Its hardware is redesigned with more natural proportions, hidden mechanics, and more refined hands capable of gripping in multiple styles. The face area is expected to include a communication screen, and the overall motion system is being tuned to replicate human movement as closely as possible. Gen 3 isn't just a mobility upgrade. It's meant to be a robot that looks and behaves like something you could actually live or work alongside daily. Tesla has also begun testing Optimus in simulated factory environments, where the robot is assigned tasks normally handled by human workers during early training phases. Engineers reported that the robot was able to place components, sort trays, and assemble small parts with a level of steadiness that surprised even the staff watching. These scenarios highlight the direction Tesla is taking. Optimus is intended not just for simple home chores, but also for repetitive and precision-based industrial workloads. Optimus Gen 4, planned for later release, won't focus on exterior design but on major internal upgrades. This version is reported to nearly double its operating time, going from around 7 hours to nearly 12 hours on a single charge. It's also designed to move faster, react more efficiently, and handle precision tasks that demand delicate motor control. While a Gen 3 model may fetch something from your kitchen, a Gen 4 model is expected to perform far more complex actions like opening containers, assembling fine parts, or completing tasks that require consistent accuracy over long periods. What makes this progression significant is the way each generation builds on the last. Optimus isn't being developed as a flashy demo machine. It's being engineered as a system that improves with every update, both through physical upgrades and software expansion. In other words, the robot you buy will continue to get smarter and more capable over time. Similar to how modern electric vehicles improve through software updates, this long-term roadmap is what sets Tesla apart. The company isn't building a single impressive prototype, it's building an evolving platform designed to become more useful every year. As Optimus advances toward full production, the biggest challenge isn't just engineering the robot itself, it's ensuring that it can be produced safely, reliably, and at massive scale. A humanoid robot operating in homes, factories, hospitals, and public spaces must be built with strict safeguards, because Optimus uses real time sensors, machine learning, and autonomous decision-making. The system must be protected against software failures, hardware faults, and any form of digital interference. If a robot misreads a command or receives unexpected input, it needs instant fallback protocols and automatic shutdown layers to prevent unsafe behavior. Security becomes even more important because Optimus can perform tasks that involve physical interaction with people and objects. If its internal systems were compromised, the impact would go far beyond simple glitches. It could lead to incorrect actions in critical environments. To prevent this, Tesla is developing a multi-layer safety framework that includes encrypted data flow, continuous system monitoring, and behavior detection systems that shut the robot down if it begins acting outside its normal range. The goal is to ensure that Optimus behaves consistently, safely, and predictably in any environment. Another challenge is the robot's ability to learn. Unlike traditional machines that repeat fixed instructions, Optimus adjusts and improves through AI-based training, which introduces new risks. The robot must be prevented from absorbing incorrect patterns or errors during its simulations. This is why Tesla's development combines AI, cybersecurity, and ethical engineering. Every improvement to Optimus's intelligence must be matched with equally strong safety supervision. Comparisons with other humanoids often lead to debates, especially with Boston Dynamics' Atlas. But these two machines follow completely different philosophies. Atlas is designed for research into agility and athletic movement, jumping, flipping, and navigating complicated terrain. It's a technical showcase of balance and motion. Optimus, on the other hand, prioritizes everyday usefulness and mass manufacturability. Its purpose is to handle repetitive tasks, manage objects without breaking them, and eventually function as a reliable helper in homes and factories. It's engineered to be practical, not theatrical. This distinction is becoming even more visible as other companies join the race. Xpeng, for example, is pushing into the humanoid field with its own robot platform, aiming for mass production within the next few years. Their strategy suggests that humanoid robots might eventually become as common as electric cars, with companies competing on features, intelligence, and battery performance. The entire industry is accelerating, and Optimus is one of the central forces driving that momentum. The real question everyone keeps asking is whether robots will replace human jobs. And the honest answer is, some of them. Yes, many basic repetitive tasks are naturally suited for machines that can work non-stop without fatigue. But at the same time, the rise of humanoid robots could bring huge advantages. People who are overwhelmed with chores, caregiving, busy schedules, or physically demanding tasks could soon rely on a robotic assistant to handle what normally drains their time and energy. The potential benefits are massive: cleaner homes, safer workplaces, more efficient industries, and support for people who need daily assistance. Even with all this progress, what Tesla has shown publicly is still only a prototype phase. Optimus can walk, bend, lift lighter objects, and complete simple tasks. But there's a large gap between these early abilities and the long-term vision of fully autonomous labor. The next few years will determine how quickly Optimus evolves into something truly capable of taking over meaningful workloads. For now, the world is watching closely, waiting to see how fast Tesla can push this technology from impressive demos to everyday reality.